Our next speaker is Michael Wang, who's a professor and founding dean of the School of Engineering at the Great Bay University in China. Take it away, Michael. Thank you.
Thank you, Peter. Good morning. Over past 2.5 days, we have heard from a number of distinguished researchers on robotic manipulation. There's really not a lot that I can add to, but I'd like to share with you some of my thoughts on robot manipulation scale learning, and as well as the role of engineering. I will put it in the context of humanoid robotics, if I can get the cursor moving. I guess not. I'll do this manually. Over the year, especially in 2024, and we have seen the frenzy wave of humanoids. And early March, Jason Wang showed up on the stage with about 10 humanoids. And in just last month, August, in Beijing, there was a World Robot Conference, and there were 27 humanoids, and they've been around there for 4 days, walking around and showing off. There is a big venture market in China as well, and in a rough estimate, there are already more than 60 companies in humanoids, either as startups or spin out from some of the very large corporations in China. And almost every week, you will hear another new one, humanoid company, coming out and raise millions of renminbi. And shamelessly, including one of my companies, and joining the frenzy as well. But I have to think very seriously what we are going to do, what we are doing, if there is any hope to make this useful and perhaps economically beneficial. So what currently these robots are able to do something, but not a lot. So this is from one of those companies. It's not my company. I would not name the company because I'm not sure it's going to be a compliment or not. But they are able to walk around a little bit, and they also showed off some of the skills, very simple skills, picking up some items and putting them into a box. But none of these are in real scenarios that are not in any of the real environment. And by large, people are talking about 3 major potential markets where the humanoids might be deployed, one of which is automotive. I'm sure you have heard of that. And I think Figure has a display here as well during this conference. But what I'm very much interested is in electronics assembly industry. In China, we call it 3C or ICT, that is information and computing technology products. So these products have their uniqueness and their challenges in assembly. By large, in the front end, from the computer chips or wafers all the way to printed circuit boards, they are almost fully automated. But at the back end, and you will find factories where a group of young workers would line up, sitting around tables, and use their hands primarily with some tools to do final assemblies, inserting some periphery components, and occasionally doing soldering, fastening screws, and also inspection and in the end, they would pack them up into boxes. And automation has been implemented in some of these, or most of these factories, to the very extent where they would no longer be cost-effective if you push them with total fixed automation. That's because the products have a number of unique features. By large, they have varieties, a lot of varieties, and most of them come in small batches. The factories are not very huge. They're small, medium companies, and they don't need a lot of heavy equipment. In the end, they have to deliver these products, assemblies, in very cost-effective and time-efficient manner. So young workers, especially young girls, young ladies with sharp eyes, very delicate hands, tend to be employed in some of these places where they've been trained, maybe for 3 or 4 days for each task, at largely using their skills of manipulation, dexterous manipulation, and hand-eye coordination. So if you look very carefully about some of these processes, you would think that humanoids might find their places, work in places like this, and 24 hours a day. They might be more flexible, agile, and cost-effective. So how do we learn manipulation skills from the workers? And if we do not learn from the workers, are there any other technologies, especially using AI and machine learning, to help us to get these dexterous manipulations learned for robots? And most of these robots need not to be a humanoid. And you see that the workstations are primary workplace for the workers or the robots, and mobility is largely not required. But mostly we need 2 arms and 2 delegated hands to be able to do all of this. For me, as a student, under Matt Mason some years ago, I was very fascinated about dexterous manipulation, but really haven't get a chance to really do much. Now today, we now understand from neurosciences, from physiology, what we are capable of doing with our hands, especially when we do the fine touch of assembly by feel, by hand-eye coordination. But we have not been able to get the robots to mimic or to acquire the skills, especially the skills that a very delicate young workers are able to do. So what are the technology components that are missing? One of which is what we are now focusing on, that is trying to figure out how to learn from humans. We know that reinforcement learning is a very powerful tool. Imitation learning has some achievements, but for the human dexterous operations in the faculty, you were not able to really observe the last fine process of getting things done. That is imparting forces and energy to get the components in the right place with efficiency. Most of the workers do this very quickly, and it's not strenuous, but in the end, it's very tedious. So they will not like to work for 8 or 10 hours a day. But what would be the tools for us to get robots to learn of this? Of course, we are trying sim-to-real, imitation learning, and learn from demonstrations, all these 2 techniques in the laboratories. But to me, we are really lack of a knowledge of human data, especially the touch and feel and tactile sensations that we use quite extensively in our skills. And there are databases, or there are platforms for collecting data, for training robots to do dexterous manipulations, but the tasks that they are able to do, or the data available for the tasks, are very, very much limited. Grasping is one big category, insertion is another, but fine texture manipulation is not much there. So I will just say that one of the technology that is lacking is the tactile sensing. Although we know there are a lot of research in the soft skin on tactile sensing, but for any dexterous manipulation without the tactile capability, you will find it very difficult. This would be a case for a young girl who lost the skin sensation for touch. So there are sensors and would help us, and we have built a particular type of sensor based on optical measurement that will give us more detailed information about pressure distribution. Especially, we are able to categorize the modalities of tactile sensing and make use of that for robotic manipulation. We're able to integrate them within the fingers of a robot hand, and we have done some work that to be able to make use of them for robot learning. But in comparison, very quickly, with the tactile sensing capabilities of the human skins, we are very much short. We already know that there are 4 types of receptors, and they are distributed over multiple places in our hands, and our sensors are far, far away from these capabilities. And there are a lot of questions. Do we need 4 kinds of receptors? Do we need all this information? And if we do, how do we achieve them? Especially, how would we be able to acquire the signals from a human hand, 4 types of reception signals, and use them to process or to teach our robots. And furthermore, in the last 10 years or so, we already know that finger schemes have memory about history of deformation. And history of deformation is used in the current process of manipulation control. And also fingers have computing powers as well. So there's still a long way to go to make use of AI. And what I'm trying to say is that robot manipulation skill learning is a big, big task, and there's still a lot of room for engineering, not only for the people to do algorithms. Thank you very much.
Thank you, Michael.
Yeah, I'm joining our